Hello everyone, welcome to the MPMC class. Um, Today we are going to discuss about pin diagram of your 8051 microcontroller. So before that we will make a 1 minute quick recap of your 8051 microcontroller features. Okay, so tell me what is meant by a microcontroller. So microcontroller is a device which consists of processor. How many bit processor it is, or how many bit microcontroller? 8-bit microcontroller. So when I am saying 8-bit microcontroller, that means it consists of 8-bit data bus and it consists of 16-bit address bus. Now what is the need of address bus? To identify the memory location of the your data, right? As it is a microcontroller, so it consists of internal memory. So what are the two different internal memories are there? One is RAM, another one is ROM. Now what is the size of the RAM of your 8051 microcontroller? It is having 128 bytes, right? And we are having a size of ROM is 4 KB. 4 KB of ROM and 128 bytes of RAM. Apart from memories, we are having some other peripherals called IO ports. So IO ports are 4, port 0, 1, 2, 3. Okay, and all these IO ports are 8-bit ports. That means it consists of 8 pins. Apart from IO ports, it consists of 2 independent 16-bit timers, and it consists of 1 serial port. Okay, these are the main peripherals where your microcontroller is having. Apart from this, we are having 5 interrupts, 3 internal interrupts and 2 external interrupts, and it is having a crystal oscillator frequency of 12 megahertz. Okay, so now in today's topic, we are going to see the pin diagram of your 8051 microcontroller. So just like your 8085 microprocessor and 8086 microprocessor, the 8051 microcontroller also having 40 pins. Okay, so what are those 40 pins functionality we are going to see in our video. Okay, now when I'm saying a processor, so processor wants to execute the program. Now whenever we are taking any microcontroller or microprocessor, you require power supply to work on it, right? So whenever there is a power supply, there should be a working device, right? That's why we are having two different signals called VCC and ground. So power supply and ground. So without the power supply and ground, your any electronic device won't work, right? That's why we are having VCC and ground. Now VCC means plus 5 volts and ground means 0 volts. That means your 8051 microcontroller is operating in the voltage form of 5 volts. Okay. Apart from power supply, now if you want to execute the instructions, what is the another important thing the processor needs? Okay, suppose whenever if you want to execute instructions, first we need to fetch the instruction, next to decode it and execute it. Now you need to tell how the processor know that I want to fetch the instruction, after that I need to decode it, after that I need to execute it. That means after completion of each and every operation, it has to complete the next operation. How the processor will know that? Is any human being will enter into the microcontroller and tapping on the back, hey processor do this, hey processor do this, hey processor do this? There will be no human being. Processor is a dead object, right? So that means the processor, you need to tell the processor to do what operations to be performed at what time. Okay, so who will do that one? That means you need to trigger the processor. Who will do the triggering? So triggering is given by the clock pulses. Okay, that is your oscillator. So your 8051 microcontroller needs a oscillator, and we need to connect the oscillator from externally. So that's why we require 2 pins, XTAL1 and XTAL2, external crystal oscillator. Okay, so whenever if you want to connect the oscillator, you can connect with the help of these 2 pins. Now whenever we have connected the oscillator, we will give the power supply to the oscillator. Whenever if you give the power supply to the oscillator, now the oscillator will oscillate. After oscillating, that means you can able to see there is a small rectangle object is there in that oscillator symbol, that is called quartz crystal. Okay, that crystal will able to oscillate between those 2 plates. Okay, whenever the crystal touches that one plate, it can generate clock pulse. Whenever the crystal touches another plate, it can able to generate the another clock pulse. Similarly, whenever the crystal oscillates, it can generate the clock pulses like this, right? Now this is nothing but the triggering pulses which is given to the processor. Now you are telling the processor in this clock pulse you do the fetching, In the next clock pulse, you do the decoding. In the next clock pulse, you do the execution part. So that's why the oscillator is needed for every microprocessor or every microcontroller. Now, what is the operating frequency? That means the clock crystal frequency of your 8051 microcontroller, that is 12 megahertz. Okay. Now we have completed the 4 pins of 40 pins of your 8051 microcontroller. Now the next pin is reset. As you can see the symbol of the reset, it is input to your microcontroller. That means whenever if you want to do the reset of your 8051 microcontroller, you can give that signal. That means whenever the reset is one, it will reset the internal microcontroller peripheral devices. Now, similarly, if you take your mobile phone, suppose you are doing some operation, that means you are using some apps, okay, suddenly your phone got struck. What you will do? You will do the restart. Okay, so after restarting, what will happen? The already which we are using the apps, all will be closed and the phone will be started from the normal again, right? Similarly, whenever if you give the reset signal to your microcontroller, it will reset the data of your processor and it will reset the data. That means it will clear the data present in the RAM. Why it will remove the data present in the RAM? Because RAM is a temporary memory. It will store the temporary data. Upon reset, the data will be erased. What happens to the ROM? ROM is permanent memory. Okay. After reset, the data present in the ROM does not lost. Okay. What happens to the data present in the IO ports? It will be lost. That means it will be deleted. What happens to the data present in the timers and serial port? All will be deleted. So except the data present in the ROM, all other devices data will be deleted. Okay, that is your reset. Now, I'm sure in your mobile phone during the restarting, you can able to observe one screen. Okay, if you take your Honor mobile phone, you can see the Honor symbol, Honor name, Honor text, which is moving in the animated form. And also if you take Oppo, Vivo, whatever it may be the mobile, so you will see the starting screen, that is called BIOS screen. Okay, so during the execution of the reset, it will enable the BIOS program. That means it will execute the BIOS program first and it will make the system ready. Okay, the next one is ALE. I'm sure if you are following the 8085 microprocessor and 8086 microprocessor, you already figured out what is meant by ALE now. Okay, address latch enable. So I already told you. So the 8051 microcontroller having 16-bit address bus. Okay, 16-bit address bus means 16-bit address bus means that is A0 to A15. Always we will start the address bus number with 0. Okay. Now this 16-bit address bus is divided into two address bus. One is 8-bit address bus, another one is another 8-bit address bus. The first 8-bit address bus we are calling it as lower order address bus, that is A0 to A7. The next higher order address bus we are calling it as A8 to A15. Okay. Next, there is a data bus. Now data bus, what is the size of the data bus? 8-bit, right? Now the Intel engineers are very intelligent people like you. What they're thinking that, so during the execution of the program, you require address first. Later we will reuse the data. Okay, before knowing the address, we cannot able to get the data, right? That means first I will use the address bus, later I will use the data bus. That means I am not using the address bus and data bus at the same time. So this is the one idea. So that's why they made that address bus. Why can't we make address bus and data bus combined together? That is called multiplexing together and form a one bus. That is called multiplexed address bus and data bus. That's why the name given as AD0 to AD7. So you can able to see I have given the different text color for the data bus and address bus. Now, whenever if you are whenever if you want to operate on the instructions, you need to have address bus and you need to have the data bus. Now here the address bus and data bus are multiplexed together. To combine it together, what you need to do? You need to demultiplex. You need to separate. So how to separate? Okay, you will take the knife and you will cut the bus into two parts? No, right? That's why we are using some other external hardware device that is called latches. So with the help of latches, I can able to separate the address bus and data bus. Now, we need to make the latch enable and disable to separate the address bus and data bus. That is a principle which we are following to demultiplex the address bus and data bus. That's why we are using one signal called ALE. So I am sure you can able to see the ALE signal is connected to the latch. Okay, whenever the ALE is 1, then it will, the multiplexed address bus and data bus acts as a address bus. Whenever the ALE is 0, the multiplexed address bus and data bus acts as a address bus. Okay, I hope you understood this concept, ALE. Okay. The next signal is EA bar. So in some textbooks, we can able to say as enable access or external enable access. Okay, generally we are calling it as. Now, we are having internal RAM and internal ROM, right? Suppose if you want to store more programs in your microcontroller, that 4 KB memory is not sufficient. Now, what you can able to do? You can connect external memory to your microcontroller, right? Now, okay, I have connected the external memory. Now, if you take your internal ROM, what is the size? 4 KB. That means if you take any memory, it has starting memory location and starting address location and ending address location. Now, what can be the starting address locations of your ROM, of your internal ROM, and what is the ending address of your internal ROM? The starting address always is 0000, 4 zeros, and ending address is 0FFF. Why 0FFF? Because the size is 4 KB. Now, if you take the ending address FFF, how you are saying it as 4 KB? How the number came into the picture? If you take 1F, 1F is nothing but how many ones? 4 ones. That means how many ones are there? 0FFF, 12 ones. That means we are having 2 power 12. 2 power 12 means what? 2 power 10 into 2 power 2. 2 power 10 means 1 KB. 2 power 2 means 2 square means 4. So that means 4 KB of internal ROM. That's why the starting address is 000 and 0FFF. Why only 4 zeros? Because the size of the address bus is 16 bit. That's why we are representing the address bus with 4 hexadecimal numbers. Okay. Now, if the internal ROM is not sufficient to store more programs or more data, we can able to use external ROM, right? What is the maximum size of the external ROM can be connected? 64 KB. Why? Because your 8051 microcontroller has 16-bit address bus. With the help of 16-bit address bus, I can able to access maximum memory of 2 power 16. That is your 64 KB. Okay. I hope I make you understood this point, right? Next, whenever we were having 2 memories, that means I can use only internal ROM, or I can use only external ROM, or I will use both the internal ROM and external ROM. So these are the 3 options I am having. Now, there is a signal called EA bar. So enable external access enable. Okay. With the help of enable external access EA bar symbol, EA bar signal, we can able to access only external memory. Okay. So if you want to access only external ROM, external permanent memory ROM, okay, we need to make EA bar is equals to 0. That means we are not using the internal ROM. That means whenever the microcontroller was reading the instructions from the memory, it will read only from the external ROM, not from the internal ROM. Why? Because we have made the EA bar is equals to 0. Now, what are the another option? I can use only internal ROM. So if you are using only internal ROM, then there is no need to connect the external ROM. Okay. That is another case. And suppose the third option is I want to use internal ROM as well as external ROM. So what is the starting address of the internal ROM? 0000, 4 zeros, and internal ROM maximum address is 0FFF. Now, if you want to use internal ROM as well as external ROM parallelly, okay, you can use with the help of one signal called EA bar is equals to 1. Whenever if you make EA bar is equals to 1, you can access both internal ROM and external ROM, but there is a catch. So what is the problem, or what is the catch is, here you can use the external ROM from 1000 memory location, 1000 onwards only. You cannot access the memory between 000 to 0FFF. Why? Why can't I access the external ROM of these particular addresses? Because suppose if the microcontroller is generating address as 0001, 0001. Now tell me, the microcontroller will be in a confused state whether from which external ROM or internal ROM I need to get the data. Why? Because if you take 0001, 0001, it is having the same address of the internal ROM as well as the same address present in the external ROM. So that leads to confusion. That's why the internal room addresses is a part of external room. So you can able to see the shaded diagram of your external room now. That means the addresses of your internal room is matched with the external room. That's why if you want to access both internal room and external room together, you can access your external room from the 1000 memory location onwards. Up to now, we can able to use the internal room. Okay. So that is a point of your external enable access, EA bar. Okay. The next signal. So while looking this diagram, suddenly you can see from this slide to this slide, there are so many signals popped into this slide. So don't worry. So we are going to see one by one. Now, if you see in the left side, there is a PSEN bar. Okay, I am going to discuss that pin in the last slide of this class. Okay, why? Because there is a most important signal which is created a solution for one problem. Okay, now take an example on the right side. Come to the right side part of your slide. So there are IO ports. I told you there are 4 IO ports. How many IO ports? 4. What are the names of those IO ports? 0, 1, 2, 3. Okay, always start with 0. So 0, 1, 2, 3. All these IO ports are how many how many bit are IO ports? 8 bit. That means each and every port consists of 8 pins. That means total how many pins for the ports? 32 pins, right? Now each and every IO port is bi-directional. So what is bi-directional? It can access both input as output or output. Okay, that means we can connect input devices to it, or we can connect external device to it. I mean output device to it, right? Now there is some other advantage with the help of IO ports. What is that another advantage is, if you look at this port 0, port 2 and port 3. Okay, each and these 3 ports except port 1, all these ports can able to work as alternate functions. That means that port can also work as some other function apart from the normal input or output operation. So what are those alternate functions? We will see. If you take the port 0, okay, the port 0 can access normal bidirectional IO port, or as well as it can also work as multiplexed address bus and data bus. Okay, similarly if you take the port 2, it can access higher order address bus. So now you got some confusion, sir, why we are having the address bus and data bus present outside of your microcontroller? It has to be inside of your microcontroller, right? So if you are having common sense, you can able to understand this point. So the memory is present inside of your microcontroller, right? That means it is having internal data bus and address bus. Now, whenever if you want to connect the data, I mean memory externally, then you require external data bus and external address bus. That's why we are using the external address bus and external data bus, and with the help of multiplexing out to the ports. Why we are using multiplex concept here? That means the port can access a multiplex address bus and data bus as well as normal IO port. If you take the port 0, now you tell me the answer whether we are using every time we are connecting the external memory. Always no. Internal memory is so sufficient. If you are not able to store more data or more programs in your internal memory, then you can able to use the external memory. During that time you can use the external data bus and external address bus. Every time we are not using the external memory, right? If you take any simple device. So that's why can't we make the multiplexed address bus and data bus combined with the port 0, so that we can able to reduce the size of your microcontroller. So if you are having 2 different pins for port 0 and address bus and data bus, we can able to increase the complexity. That's why the Intel engineers, intelligent people like you, they think that why can't we make the multiplexing concept to make the address bus and data bus to multiplex with the port 0. Okay, and the higher address bus is multiplexed with the port 2. Now if you take the port 1, it is not having any other additional functionality. Remember my point? So there is no alternate functionality for your port 1. Now take the port 3. So port 3 has major alternate functions. So you can able to see first 2 pins is nothing but your port 3.0 and port 3.1 is nothing but your TXD and RXD. It is nothing but your serial port pins, and next 2 are interrupts, next 2 are timers, and next one is control signals. So we are going to see one by one in the subsequent topics. So by default, we can use port 1. Why? Because port 1 does not have any alternate function. So whenever, if you want to do the programming on the ports, the first choice, obvious choice is port 1. Okay. Now, what can we do with the ports? We can connect input or output devices. Now, can you able to see this figure? What is this figure means to you? So during your childhood days, you have used this piano, right? Piano. Even you can able to see nowadays also your cousins, small kids are they are using. So this is 8-key piano. So that means there are 8 different buttons. Whenever you are pressing one button, it can able to produce some different sounds. So if you know the music, sari gama pada nisa, so 8, right? So that's why we are having 8 different keys to produce 8 different sounds. Suppose this is a simple device. There are 8 different buttons and there are 8 different sound devices. Why can't we make, can you make this system with the help of microprocessor? You cannot use a microprocessor here because we are using only simple system, a simple program. Why are using the motherboard here? Okay, that's why we'll use some microcontroller. Now tell me how to make this device. We need 8 buttons, right? There are 8 buttons. 8 buttons are nothing but push buttons. Okay, there is a difference between switch and button. So what is the difference between switch and button? Switch, whenever if you press, it will keep on in its state. Suppose on means on, off means off. Whereas push button, whenever if you press, it will turn on. Otherwise, if you release, it will turn off, right? That means it will give the 1 whenever you press. It will give the 0 whenever you won't press, right? And what are the another thing we need? There are 8 different buzzers. This is called sound devices. Buzzer is also known as sound device. I hope you see these buzzers somewhere in your bikes. There are left indicator, right indicator, kick symbol. Whenever if you hit the indicator buttons, right, who will give that sound? This is a buzzer. Okay, suppose if your bike or car is not producing that sound, that means the buzzer is gone. So you need to replace that buzzer. Now, can you, what are the different input devices here? Input device are your button, output device are your buzzers, right? The next we can able to add some other additional functionalities, LEDs. For each and every button key pressed, you can able to turn on one LED as well as buzzer. Okay, that means your LED is your output, buzzer is output, and your buttons are input devices. Now all these things are connected to your microcontroller. You will write the program. So based upon the key I pressed, I can able to turn on the buzzer, subsequent LED also. Okay, with the help of buses, I can able to connect it. So with the help of buses means I'm saying ports. With the help of ports, I can able to connect these things. So how many ports are needed in this example? Only 3 ports, because 8 for buttons, 8 for buzzers, and 8 for LEDs. Still we are left with the again 8 pins. We are having 4 ports. We are using only 3 ports here. Okay, the simple system we can able to develop. Now, what will be the alternate function of your port 3? We will see. So whenever if you see these serial port, interrupts, and timers, these are the some of the biggest topics in your 8051 microcontrollers. Okay, for each and every topic, normally it will take 3 to 4 classes. Okay, whenever we are discussing that serial communication, interrupts, and timers, during that time we are going to see in detail what are those things. Okay, meanwhile I will give you the some brief idea of about these pins. The first 2 pins are TXD and RXD. The first 2 pins are assigned to 3.0, port 3.0 and 3.1. Okay, 3.0 is TXD, 3.1 is RXD. What are these 2 pins? Suppose whenever if you are want to interface serial communication devices, I am sure you may you know that Bluetooth, Wi-Fi, Zigbee. Okay, these are all called GPS, GSM. These are all called serial communication devices. So what is serial communication? If you want to transfer the data 1 bit at a time to the long distance, we will use a serial communication. To support that, we are using serial communication devices. Now the devices, if you want to connect to your microcontroller, then you can need to use 2 pins, TXD and RXD. TXD means whenever you are sending the data from microcontroller to the serial device, you will use the TXD. Whenever if you want to receive the data, you can use the RXD device. Okay, the next 2 ones are INT0 and INT1. I told you there are 5 interrupts, 3 internal and 2 external. So these 2 external interrupts are nothing but INT0 and INT1. Okay, what is meant by interrupt? So generally we are using the interrupts to pass the to execute the program which is highest priority than the main code. Take an example. This is my main program and I am having some instructions in the main program. While executing the instruction 2, I got an interrupt. So what happens if I got the interrupt? So it will pass the main program that service is go back to the interrupt service routine. It is nothing but like a function in your C language or any other language. Okay, so if you want to call a function, go to the function, execute the code, again come back to the main code. Similarly here, whenever if you got interrupt is, whenever you got an interrupt, the interrupt service routine, that is means it is having some code that will be executed. That means there is set of instructions, that is your program. That program is executed, again it will come back to your main program. This is nothing but the interrupts. And we are having two external interrupt. That means externally we can also interrupt your microcontroller in a two different ways. By default, the INT0 is having the highest priority. Suppose we are giving the two interrupts at a time. So which interrupt we request will service first by your microcontroller? That is interrupt 0. By because that it is having the default priority. That means I can able to change the priority of the interrupts. Okay, when we are discussing the interrupts, we can able to see in detail about the topics. Next one is timers. Now timers is used to generate the delay. Okay, how much delay you will need? You will need in microseconds or milliseconds. You need to get the delay in milliseconds, minutes, hours, days. Okay, sometime months, right? So if you want to get the delay, you need to give the frequency. Now the frequency here, if you take, there is a oscillator here. I can able to give that frequency to the timer. Now what is the crystal frequency of your oscillator? 12 megahertz. With the help of 12 megahertz, I can able to get the delay only in milliseconds or microseconds. You cannot able to get in seconds or minutes or days. That means you need to use slow clock. That means slow clock frequency. So if you take 12 megahertz, is the highest clock frequency. It is having high clock frequency. If you take some other clocks which is having 10 megahertz, sorry, not 10 megahertz, 10 hedges or 1 hedges. Okay, this kind of clocks, if you are giving to the timer, it can be able to generate the delay in the form of minutes, seconds, hours, days, etc. Okay, we are having two different timers. That's why we are having two different inputs to the timers, T0 and T1. T0 is given input to the timer 0 and T1 is given input to the timer 1. That means whenever if you want to give the external clock to your timer, we can able to use these two pins, T0 and T1. Okay, the rest of the two remaining, there are three pins in this topic. We will see what are those three pins. Now, suppose whenever if I want to store more data or more program, I can connect external memories. External memory means I am having two memories, ROM as well as RAM. Can I connect external RAM? Can I connect external ROM? Yes, you can connect either external RAM and external ROM. Each and every starting having address of 000 and ending address is FFFF. Why? Because it is having 16-bit address bus, your microcontroller. Now, whenever if you are accessing the data from the externally, the microcontroller or your internal microprocessor has to generate the control signals. I am sure you know the control signals in your 8085 or 8086. Read bar, write bar, okay, address latch enable, IO/M bar. Okay, so now we are using two control signals, read bar and write bar. We are not using IO/M bar control signal here. Why? Can anybody tell me that answer? IO/M bar, that means whenever if you want to read the data from the input, I mean IO port or from memory, I can able to differentiate with the IO/M bar. But here, if you take IO ports are present inside your microcontroller. That means there is no need to generate external control signal. Okay, that's why whenever you are using external memory, then you need to generate the external control signals called write bar and read bar. Now tell me to which memory I need to use these control signals, read bar and write bar. So if you are telling the answer for the both memory locations, I can use the read bar and write bar. Okay, that's good. But if you are telling I can use only the read bar and write bar, both the signals to only external RAM, that is perfect. When you say I can use the read bar and write bar both signals to the external ROM, then that is a stupid answer. Why? Because if you take the RAM, random access data, that means we can able to write as well as we can read, right? That's why it requires two control signals called read and write. Whereas ROM, can you able to write the data in your ROM? No, because it is a read only memory. You can only read the data. That's why it require only one read signal. But here these two signals are used to read the or write the data only for the external RAM. Now you got a question, sir, how can I read the data from the ROM? Can I use the read bar here, the signal which I am having? You cannot use that read bar signal here. Why? Because if the external ROM and external RAM share the same read signal, now if the microcontroller generate the read bar signal, read bar is equals to 0. Now microprocessor in the confusion state whether I want to read the data from ROM or RAM, because the same read signal is given to the ROM and RAM. Okay, that's why the ROM and RAM does not share the common read signal. Okay, now tell me what is the another signal we can use? There comes the part of PSEN, program status enable. PSEN bar, I'm repeating, program status enable. Now whenever if you want to read the data from external ROM, then we can able to generate one control signal called PSEN bar by the microcontroller, so that we can able to read the data. Okay, now with this import, I told you this is one of the most important signal in this microcontroller. With this signal, I have solved one problem. Okay, what is the problem here? So I'm using two different memories, right? ROM and RAM. Can I use both memories at a time? No. Why? Because I can access only 64 KB ROM or 64 KB RAM, right? Why? Because it is having 16-bit address bus. Now with the help of only read bar, I cannot able to read the data only from both the devices. So with the help of this signal, I can able to read the data from the ROM, and with the help of another signal, I can able, that is called a read bar, I can able to read the data from the RAM. That means I am accessing the memory of 128 KB here. Look at the diagram. We are having separate 64 KB external ROM and we are having 64 KB external RAM. I am reading subsequently, I am reading parallelly that data. Right here, with the help of PSEN bar, I am reading the data from the ROM. With the help of read bar, I am reading the data from the RAM. So that's why it solved a big problem to access more memory with the help of your 8051 microcontroller. That is your 128 KB. Actually, the actual physical size is 64 KB. But with the help of PSEN bar, with additional signal, I can able to access the data from 128 KB memory. Okay, that means separate from the ROM and separate from the RAM. So that means that is the end of this class. I'm sure you have enjoyed this video. So if you're having any doubts, you can please personally ping me in your WhatsApp or type in this chat box, or you can unmute your mic and you can able to ask.